Oh, hi people. Hi to everyone. Okay, I hope I'll be able to finish this before my phone switches off. Hi everyone. Yeah, so it's been quite a while since I last uploaded a video of anything. Just give me a minute to sort this out. I will be done in just a second. Okay, cool. So this must work. Okay, cool. Okay, hi people. I hope you're all good. I'm just testing to see if all the cameras are working. Anyways, yeah, I hope you're good. I've got here with me, it's a Dell Latitude 3520. Yeah, it's a Latitude 3520 and it's working. It's not working actually. It's literally not working. I'm mistaking it with another one which is working but having issues. Anyways, if I plug a charger to it, this laptop is just drawing 20 milliamps. Yeah, 20 milliamps. That's all it's drawing. So let me show you guys there. You can see there, it's like it's on standby, ready to start working, but it is not. If I press the power button on it, just down there, there is no response, nothing at all. It's not responding at all. Anyways, even if I'm using a Type-C charger, I've tried with the Type-C charger. Give me a minute. Yeah, I hope you can see from there. Yeah, definitely. So I've got a Type-C charger here with the Type-C amp meter, and if I'm plugging it in, what do I have? It's negotiating 20.06 volts, but it's taking in 0 amps. So this tells me that the charging IC, whether it's an ISL or it's a Realtek or whatever it is working, because it's communicating with the charger requesting 20 volts. So that means our issue is not with the charging. It has to be somewhere else. So yeah, what I've done is when I opened it initially, there was liquid. I could see clearly that there's liquid. This is just a few minutes ago, right over there. So what I've done so far, I've already removed the MOSFET which was there, transistor which was just over there. There. So I removed it and I replaced it with this one. And I also connected a jumper wire there, but still we have the same result. So I am quite sure our issue is elsewhere. Anyways, I think we can step down and start from the basics. Yeah, basics of laptop repairs, which is you follow the power flow from your input, which is your charger, up until you get to your secondary power rails. So let's go. Let's plug in a charger there and we check the voltages that we have. So still taking 20 milliamps, which is gonna drop to 10 milliamps really. So usually, like if you see a laptop doing that, you'll be convinced that laptop is supposed to switch on. Anyway, so from the charging port, we know we do have our 19 volts there because it's taking 10 milliamps. So we do have our 19 volts over there. We can look for our main power rail. So main power rail, you can find it from almost anywhere. Let's just find somewhere. What do we have there? 12.58. So yeah, we do have a main power rail. Here's the multimeter. I'm gonna place it like this so that you guys can see. So yeah, this is a Dell, and you know Dell doesn't in these types of motherboard, they don't use the 19 volts main power. They started using the 12 and the 13 volts. So 12.58. So yeah, we do have main power. Let's check it over here. 12.58. So yeah, main power is present. We are good. And this motherboard actually has a graphic card. I think it's an i7 7 gen or 8 gen. I'm not so sure, but it's somewhere in that generation. Anyways, yeah. So we do have our main power. I have happened to search for a schematic, which is what you can see here. I got it from Discord. Anyways, let's see. Let's view the schematic diagram. So this is where I am actually. I'm following the schematic diagram based on this. So our power flow chart is right over here. So what does it say? It says you've got your charger, your battery, whether it's type C or the barrel goes in there. The ISL controller creates the main power rail, and it also creates for the battery. And then from the battery or from the charger, you get the main power, which is power SRC. So from power SRC, we do have this one. Let me try to zoom in so that you guys can probably see better. So from there you can see we've got PU200 over there, and it's generating for us 1.2 memory, but this is not a primary power. This is not a primary 1 volt. Some machines they have this as a primary power. We've got the 5 volts, of course, and we've got the 3.3. So we're looking for these two, 5 volts and 3.3. However, what I noticed is that this motherboard, it's not like your typical motherboard. Typically, we'll have here when we get here by the power states. So here by our S5, S4 AC, we would have here only 5, 3.3, 3.3 PCH, and 5 volts always, something like that. We'll just have 4 or 3 here, but we've got a huge list right over here. So this laptop, when you just plug in the charger like this, you're supposed to find all of these voltages, all of them. And then when you plug in the charger and you switch it on, you're supposed to find all of these, and all of these. If it's suspended in sleep mode, you're supposed to find all of these and all of these, which is this one, the S3 power state. And as we're concerned about S4, because this is where we are right now, we just plug in the charger, it's not switching on. So we're supposed to find all of these voltages. So yeah, we can check them out. Let's find on the coils. We're just supposed to find basically 3.3, 1 volt, and 5 volts. So we can start checking for those. So usually we all know that our 3.3 and our 5 volts, they are usually somewhere close to each other. So let's just check it out here. Let me put this in diode mode. Okay, so probe to ground, remove the charger. I'm looking for a voltage actually. What am I doing? I'm looking for 3.3 and I'm looking for 5 volts. So I'm still taking 20 milliamps. What do I have there? 0 volts, 0 volts. I still have 12.58 on the input. What do I have there? 19 volts, 1.4. This is going to the charger there. Over here we do have our 12.58 coming in, and we've got 0 going out. Got our 12 coming in, 3.351. So this is our 3.3 volts power. This one over here. just over there. I'll try to bring it to a clear area for you guys to see. So we do have 3.3 volts over there. Got a small inductor there, it's giving us 1.7. So 1.7, I'm sure that's this one over here, 1.8 prime. I'm quite sure that's the one. So we've already found 3.3, 1.8. We will probably have to find 3.3 PCH. It has to be there somewhere. We still haven't found 5 volts. So what do we have there? We've got the 1 volt. So we have the 1 volt prime there. So we found this one. I think, or it could be the last one, 1.0 volts MPH, whatever. So that's 1 volt over there, 0, 0, 0 over there, 0 over there. So here we're expecting 0 because these are going to the CPU and the graphic card. Okay. We still have 12.58 coming in. 0, 0, and I think I saw 2 inductors at the back. Yeah, right over there. Those 2 there. Right over there. Check them out. Still have our charger plugged in. Got another 1 volt there. So yeah, we've got both 1 volts now. Both of them, they are there. We've got 3.3, we've got the 1.8. We don't have 5. We don't have 5. Yeah. I didn't get 5 volts on this. Oh, I'm sleepy. Okay, let's see where is 5 volts coming from. We saw it over here, 5 volts always, 5 volts always, 2. Both of them, they're coming from this one. So you can see all the 3.3 for RCT, whatever, they're all coming from one chip. So if we've got 1, I'm quite sure the rest are there. And then the 5 volts, it's coming from the PU102. PU102, which is the one that I was searching for over here. PU102. So I've got 19 volts, our power SRC there coming in, goes into the chip, and then it goes out as the 5 volts. So this chip, it's actually a driver MOSFET, as some people might call it. It's got both MOSFETs inside, and it's got both the MOSFETs inside. Let me just try to zoom out this. It's blocking some stuff there. Anyways, this chip has got both the MOSFETs and the controller in one thing. Yeah, it will just receive a signal to enable, and that's it. So where is it located? PU102. It's located by PL101, which happens to be, since I found 2.3, it's supposed to be there. 201, 100, 301. Huh? Oh, 1301, 401, 611, PL 1601, 1400. How come I don't have that inductor? Oh, there it is, PL101. So it's right over here. I couldn't find the port view for this particular device. So the inductor that I want is right over there. That's the one, PL101. So let's check what we have there on the output. Plug in a charger and we check it out. We've got 0 volts there. Okay. It's working with PU102, which is supposed to be at the back because there's nothing there, you can see. It's just an inductor there. Just have a coil over there and no components, nothing else. So it has to be at the back, which it is, PU102. Yeah. So is it receiving the voltage it requires? 12.58, and the output is in what? pin number 20 and 19. So we've got pin number 1 there, 5, 10, 15, 20 should be there. Yeah, we've got 0 volts on the output. Okay. Can check for a short on the pins around there. We've got a short. We've got a dead short on the output on pin number 20 and 19. The caps around there are fine. Let me zoom in on it. So we're working over here, right over there, and as you can see, pin number 20 is this one. There's 2 there, so you've got 1 to 5, 6 to 10, 11 to 15, then 16 to 20. So the output there, it's got a short. We have got a dead short right over there. Trying to focus on there. So yeah, we've got a short over there. Yeah, it's a dead short, no doubt about that. Anyways, let's inject voltage, because that's the only way we can know really. If we had a board view, we would click on it and then we see where it's headed. Then we just go there one by one. So we inject our voltage from the coil there. So I do want to remove the CPU heatsink. Yeah, let's remove the heatsinks, because they will probably start absorbing the heat and we won't see the dead component. Okay, let's inject voltage there and see what we get. 2 more screws, take them there. The fan. Okay, so we've got the motherboard right over here now. So trying to make sure that the whole motherboard is in frame actually. Okay, so I think this is enough. This is in frame enough. I'm gonna use my my phone. It's a Cat S60. Cat S60, and yeah, it's got thermal camera in it. So instead of having to feel the temperature with the skin on my face like I used to, nowadays I just use this one. So fire up the flare app. Okay, just want to make sure that everything is visible there. So of course we will have some spots which are glowing there, but that doesn't mean they are shorted. So we're injecting voltage right over there. Don't mind my hand. Okay. Yeah. I don't know, is it just me, but I think there's something right over there. Oh, the phone is out of frame. Okay, here's the phone. So I'm gonna inject voltage now. I don't know, but I think there's something glowing over there. Right over there. There. Yeah, there, right over there. What is there? Oh yeah, it's a dead cap. It's a dead cap. There's a dead cap over here. It's completely blown. It's like there was liquid around there. It's like, let me check it off. I don't know if it's just one or all of them, because they are all discolored. They all look dark brown, blackish. Okay, but this one is clearly dead, and the shot is gone. There's no shot. Let's check it from the coil side. Yeah, the shot is gone. What do you know? That short circuit is gone. Okay, let's put the heatsink back and we test this motherboard. I might waste my time actually. Let me just plug it in and see what happens. It's on. It's on. It's now drawing 1.4 something amps. Let me see if... Yeah, it's on. It's on. I don't want to keep it on for long because there's no heatsink there. I don't want to bend things. Let's put the heatsink back and we test it. Okay. The GPU. Yeah, this looks like a good motherboard actually. Like it's usable. Of course the laptop would be big. 15. Nowadays we're chasing after 13. 13 inch is the most ideal size. 14 is not so bad, but 13 is just on point. It's not big, it's not small. 12 is not small. 12, 11, that's not small. But 13, that size is just amazing. Let's plug what do we need? We just need the fan, which we've already plugged in. We need the display and we need the keyboard. So the keyboard comes from this connector over there. Okay, so I need the backlights actually, which I'm not sure. I think it's this one, because I'll need to see if the laptop is active. Otherwise, what's it at? Okay. Okay, let's plug the power. Yeah, it's drawing 1.68, 1.67 amps. Not bad. So yeah, you can see over there, it is now drawing 1.59 amps. Do we have a display? Nothing yet. And the heatsink is not on. The fan is now spinning. Maximum fan speed, and it's off. I'm sure it's gonna restart because the CMOS battery is off. Okay, it's not restarting. Let's see why it's not restarting. This ROM module is what? Yeah, it's dead. Looks like it's got liquid damage on it. Do I have PC4 in here? Yeah, I think I've got one here. Okay. Plug the power. 1.45. Less than last time. 1.40, 1.3. Now it's fluctuating. Yeah, now it's jumping up and down. which is ideal, which is what we want actually. So 1.38, and what else do we have? 1.44 maximum fan speed, and it's off again. Yeah, it's off. Okay, so it is switching on and then switching off. In this behavior, it usually comes with a faulty RAM module or RAM slot. 1.5, 1.49. Okay, and it's stuck on the same figure. At least if it fluctuates, 1.45, 41, yeah. If it fluctuates, then you know it's cycling, it's power cycling or something like that. 1.42. Okay, I think it was 1.45 maximum fan speed, and then off. Okay, it's going off and then it doesn't start. Let me try to start it. Okay, I can see the keyboard backlight there, but I've got no display. 1.49, 1.42, 43, still not display. At this point, I'm quite sure it has to do with the RAM, the LCD cable, or something that I've plugged in. Okay, let me try to start it a third time, because remember it has to restart 3 times. So probably it needs me to start it up 3 times manually instead of it doing it itself. 1.45. 6. 1. Again, maximum fan speed and then off. Any other RAM module? I'm gonna try that one. Just check the RAM slots. So the CPU is actually getting hot. It's possible that this laptop is just getting hot because I've probably removed the thermal paste. But if that was the case, the moment I switch it on, it's supposed to start with maximum fan speed. Because by default, the moment it notices high temperature, it's supposed to ramp up the fan. Okay. So it's exactly the same as it was doing before. Oh no, it's not. It's not. This time it dropped to 0.92. Now it's off. And it's restarting on its own. This is nice. I'm quite sure this is what I'm looking for. So you can see now it's drawing less. Do we have a display? .86. Off again. Let's see if it's gonna change. 798. You can actually see display if there is from the small screen on top there. Yeah, we do have display. Dell. There you go. So it was just a matter of cleaning up the RAM slot. This motherboard is working now. Nice. So yeah. So just a recap of what we did on this.
So just a recap of what we have done on this. We had a short.
This motherboard repair. We had a short on the 5 volts, always P. Yeah, that's where our short was coming from a dead cap over there, and it was blocking the laptop from having 5 volts. And as you know, 5 volts, it's actually a primary rail, as you can see over there. Even if the laptop is off, it's supposed to be present, supposed to be on. So since it was off, there is no way this laptop was gonna work. So you can see it there, 5 volts always was supposed to be present, and we didn't have it. So even this one, 5 volts always 2, they are both coming from the same chip, which we noticed over here from PU102, and they were not present. So that's what we were facing. And now we're good. This motherboard is good now. I'm just gonna check if there's liquid anywhere else, and then I'll clean and send it off. And as for now, that's it, guys. I hope you learned something, and as always, I'll see you in another one. Cheers.